So then we can go to functions. Functions. So what are functions? Functions are basically blocks of code that will only be executed when that function is called. So as you saw before, if we go to a Python file, we will just run every line of the code step by step. But if the interpreter comes across a function, it will not execute that block inside that function until that function is called later on in the code. I will give a quick example after I go over these other 4 points. So a function is defined using the def keyword. Yeah, we'll see that later on as well. And you can call a function using parentheses. So, not the square brackets anymore, not the curly braces, but parentheses in this case. You can pass arguments, and a function can return arguments. So, yeah, let me first make a very simple example here. I'm going to exit here. Okay, so I'm going to make a very simple Python script again. Actually, let's use so let's use this script that we used before, which looked like this. If we, this will go faster. If we run this code, Python, and then hello world.py, we can see that it prints hello world as we saw before. But now let's put this in a function. So we define a function we call main, again with these double dots, which you have to put at every definition of a function, conditional, or any loop. So now this print hello world exists in this function main. And we save this and we run the code. And you see that nothing gets printed. There's no hello world. That's because the interpreter went through this code and saw, okay, this is a function. So everything that has this indentation here from now on will be considered as a part of this function and will only be executed if this specific function is called. So what would that look like? How can we call this function? Well, we can simply do this. So in the slides I mentioned, you can call a function using these parentheses. So that's what I'm gonna do. Get back to this. So the interpreter will go through the code as follows. So it says, okay, this is a function. There's indentation here, so this part is part of the function, and then it goes to this part, and this is no longer part of the function because it's all the way to the left again, and this one is calling this function explicitly. So we run this code, and you can again see that we get printed hello world. Okay, in the slides I also mentioned that you can pass arguments to a function. So what that would look like, for instance, is this. So this is my name. I say that we expect a variable here that we call name. And then I just do print hello Alex. Sorry, name. So we run this code and it says hello Alex. And if we change this name to Joppe, then if we run the code, it says hello Joppe. So that's how we can pass, in this case, a string, but you can pass all kinds of variables. And a function can also return variables. So let's say, let's make something else. Let's make a function multiply that takes in 2 arguments, an x and a y. and it returns the multiplication between these two. So we can call this function multiply, and we give it two variables, 2 and 5, and we call this result, for instance, and then we print our result. So the result is 10. So you can see now we passed two arguments to this function multiply, and what it returned was the multiplication between the two, and that got stored into this variable we call result. Yeah, so that's basically how functions work. Okay, so this is a bit one step complexer maybe, but not that much. So I'm gonna get into this part a few slides later, but just for now, assume that this is true. So we get into this if statement, which means that we run the function main. And in main, we assign the variables x and y. They're equal to 1 and 2 respectively. And then our new variable z is calling the function mean with these two variables x and y, which returns, as the name implies, the mean value of the two. So it adds them up and divides them by 2. And then if we print z, then I forgot to put the output in the comments here, but print z would in this case return 1.5. So yeah, considering this thing that you saw here at the bottom, we're gonna get to that in the slide after this one. So there's some Python specifics that I wanted to go over. Every language has their specific quirks, and I think these are the most common one, commonly used. And so I want to just quickly go over that. So first, special variables. So Python has pre-declared some variables that already have a value. And the most common one there is this underscore, underscore, name, underscore, underscore. So all these special variables are prepended with 2 underscores and also with 2 underscores. And in speaking terms, this is often referred to as dunder. Instead, every time you have to say underscore, underscore, name, underscore, underscore, you can just say dunder name or dunder REPR. Okay, so we have these special variables, dunder name and dunder REPR, and they have a specific value, and I can best show that through an example again here. So do we still have that one? Hello world.py. Actually, get .py. So let's go back to our very basic function. Let's see, we had this function hello world, and we could run this Python hello world, and I should have used this one. This one was old. Sorry about that. Okay, hello world. .py. Yeah. So we have this function, this very old one that we had before, and we can execute this hello world.py, and it prints hello world. That's what we saw before. All works perfectly fine. Next thing we saw is that if I define this function main, this is getting called like this. And this works as well, also prints hello world, nothing on the hand. Now, if I type this, I can execute this, and still prints hello world, which tells us already, okay, apparently this statement is true. But why is it true? So Python assigns a value to this variable called name, dunder name, and the value that it assigns to is dunder main, and then a string of that. And why does it do this? It only does this for the Python file that you're explicitly executing. So if I run this file, it will set name to main, and this holds, so it executes this function. Now let me quickly create a different another Python file here. So I'm gonna call this I don't know, test.py, and that will be, oh, I already had a function, a file that was named test.py. I'm not very creative with names, as you can see. abc.py. So we have abc.py, and what abc.py will do, it will import the other file, and we'll go over imports a bit later on in the presentation. But with imports, you can get, how do you say it? Load in a different Python file or package, and then you can use these functions that are defined in that file yourself. So, but what import also does, it already executes the file that you mention here. So let me just quickly make this main again. No, actually, no. Let me not do that. Yes, let me do it. Okay, so this is hello world, and I can now execute abc.py, and it prints hello world because we import hello world, and as we saw before, this executes this code. If now I enter this if statement again, and I run ABC, nothing gets printed. And that is because, as I mentioned before, dunder name is set to main in the file that you explicitly execute. So in the file that we're importing now, this is not explicitly executed because this is the file I'm in here. That is the one I'm explicitly executing. So in this file, dunder name is set to the name of the file. So I can show you that quickly by printing this variable. So if I run hello world explicitly, it prints main and then executes this function. But if I run abc, then it only then it prints hello world. That is confusing because the file name is also hello world, but it's hello underscore world. So it's not printing this; it's printing this name, which is now set to the name of the file. Sorry for the lack of creativity. Okay, so that is what these special variables are. There's a lot more, but I don't think it's really useful to get into these right now. Next to that, Python has a lot of built-in methods and functions. By the way, methods and functions mean exactly the same thing. They just get used for the same things, and don't get confused by that. Method is a function, function is method. So they have these built-in functions like abs, which returns the absolute value of a variable you put in, max, which returns the maximum value of a list. And we have type and print. Well, you've seen me use print a lot already. Print is probably a function that you're going to use the most often of all the functions because it prints a value of a variable to your console. So you can use that a lot for debugging. And type is also very useful because you can see what the type of a certain variable is. So if I no, oh, I already have it open. Sorry. So in this one, let me get rid of this. if I create x is 1, I can print type x, and what this will print is type int, so it will show me that x is an integer. And if I make this hello, then it will show me that x is actually a string. So this is also something which is very useful for debugging. Okay, so no semicolon at the end of the line. This is mostly important for people that already have some experience with programming in different languages, because nearly every language requires you to put a semicolon, so dot comma, at the end of every line of code you write, because then that tells the compiler, okay, this is the end of your line. Python doesn't need this, so that's convenient because it's often forgotten. And then modules. So modules is something I want to. Oh yeah, okay. Modules is something I want to get into a bit more. So this is where I would have told the Anaconda story. But I think if everybody was here during the break, if someone missed the explanation on Anaconda, please tell me. Otherwise, I will just skip this. Or even if someone needs a refresher on this. I think we're good. Okay. So importing modules is what you just saw me doing at abc.py. So I could import hello world. And what this does is it executes hello world, and it allows me to use functions and basically everything that I define in here. So let me get rid of this for a second and just define, oh, sorry about that. Define a variable x, which I will set to 50. Let me create a function main that returns, that prints, maybe print, this is the main function. Okay, now that I imported a hello world here, I can access all the variables and functions that are inside that module. It's called a module, but it's basically a Python file. So this module, hello world, I can access every variable and function by using the dot operator. So simply a dot, like this. I can use x. I can print that value for you. This Python abc.py. And you can see it prints 50 because this is the variable x inside the hello world module. If I just type x, it doesn't know what it is because x is not defined. So you have to explicitly mention where it came from. Or there's some other things you can do. You can also, instead of importing an entire module, you can export specific functions and variables from that module. So you could say from hello world, import x, for instance. If we run this, it knows what x is and it prints 50. Okay, you can, yeah, okay, let me just keep it to that for now. So I can also access the functions hello world dot main. So now we're calling the main function inside hello world, and what it does is print this text. So let's see if it does this, and it does. Okay, the reason. Okay, I'm not going into this. It's not important for now. It prints the result function. Okay, so that's basically how you can import modules. And this also pretty much covered creating modules because, well, this module hello world that I'm importing here is one I created here. So it's basically just creating a Python file and then accessing that Python file by importing it. If you want to, you can import this. Okay, so now for now I imported hello world, which was a Python file that exists in the same folder as that I am in right now. So it searches the folder that I am in, and it checks whether a Python file exists that is called hello world, and it does. If I import hello Mars, and I try to run this code, it will give an import error because it doesn't know this module named hello Mars. Yeah, I'm gonna, okay. Let me create this module here. So Python, sorry, I get it. Hello Mars.py, and I'm gonna write print. This is the hello Mars module. Now, if I execute, if I execute the code, Python ABC, it's still, oh, sorry about that. It still gives an import error because it cannot find hello Mars. But that's weird because we just created hello Mars. But let me just show you in a more Windows-like folder structure. In this folder that I'm in, I have this ABC file that I'm running, and I have this hello world file that I'm importing. But so it's checking for hello Mars in this folder, and it cannot find it because hello Mars exists in the folder below. So I would have to look it up, but you can go one folder structure behind. But it's not really the point of the story. It's more that the first thing that that your interpreter searches, the first location where your interpreter searches for modules is inside the same folder that you're in. But there's also other folders that it will search through that are set by your Python path environment variable. And we can quickly see what this is. So sys print sys.path. Yeah. So Python ABC. So we get this whole bunch of paths that our interpreter is searching for the modules that I'm importing. So the first one, as you can see over here, is home Alex tutorials Python tutorial compiled interpreted. So this is the folder that we're currently in. And after that, there's a lot of folders that depend on every different PC where Python is installed and where those packages are defined. So if you install a package from the internet using pip, like pip install, they get stored in these dist packages or side packages, depending on what kind of package it is. But so pip stores them in one of those locations that your interpreter searches for them. Okay, so a hacky way to solve the problem we just had before, if I wanted to import hello Mars, for instance, I could first import sys and then say sys.path append, and then I could write this. Oh. I think this is, so I put it one folder below like this. Put hello Mars. Let's see if it can execute the code now. Python ABC. Yeah, so now it finds the hello Mars module because I appended the location of my hello Mars module to this list of paths where my interpreter is searching for them. So sys.path was the list with all these folders, and append, as we saw when we were talking about lists, is appending an element to that list. So I appended this location, and then I could import it. Okay, so that's basically all modules, I think, and that was basically an introduction to Python, so to the beginning principles of Python. If there's any questions or...
I also think that important to mention at the end, especially with the module part. Maybe it was difficult to follow now, but the structure, I think that's the main message here, that everything could be connected, maybe. So you can download Python scripts from the web, and if you do the right things in your own code, you can include them as well. And I think you try to show us how to include those external sources in your code so you can use them. And yeah, I would say we're also recording this, so if you thought it was a bit difficult to follow, just have a look at it again, especially when you need it. Because I used to, still, I think this is sometimes really difficult for me to understand how it works. So I really liked that you explained it this extensively.
Okay.
But that's just a small side note that I want to give.
Yeah, thank you.
And maybe a practice would be nice to see what we learned now.
Okay. So can you guys write a function that takes in a list of integers as input, and then it returns a list of all the even numbers that existed in the list that you gave it. You can also just do this, actually, just so in input, let's see, 3, 4, 8, 10, 11, 15, 16, and then the output of your function should be 4, 8, 10, 16.
Yeah, so I got all the even numbers, but I'm not sure that I did use the modules, which because I just made the list with number for number in the list. If number is the module 2 is equal 0.
I would like that.
Yeah, very nice. So you even used list comprehension.
Yeah.
Cool.
I don't know if that's correct, but I got
it sounds like a good solution. So let's call the function get even numbers or something, and we take a list of numbers. That's our input. And so Suzanne used list comprehension. So that would mean that we would return number for number in list of numbers. So this would return the entire list that we got passed to us. I can show you. List is this one. Get print get. Okay, result is get even numbers my list print results. So I can run this. Python ABC, and you can see we just basically it returns the entire list of numbers here. So then we have to add some condition that it only adds the number to this list if for that number this condition holds. So in this case, indeed, we need to check whether it's even. That means that the modulus of 2 equals 0. Oh, sorry. So because modulus was returned, the number that remains after we have subtracted 2 from number in this case as many times as possible. So in case if we put 1 there, well, then, oh, actually this might, let me check. Oh no, it works. Okay, so if we put an uneven number in there, then the remainder is not 0. So how often does 2 fit into 1? 0 times. So what is the remainder? It's 1. So it's not equal to 0. How often does 2 fit into 3? Once. What's then the remainder? 1. So it's not equal to 0. And with 4, we put the remainder is 0. So it's true. So it's appended to this list. Well, and it does so for every number. And yeah, even numbers are therefore appended to the list and odd numbers are not. So how would we adjust this function such that it would only return the uneven numbers?
I think doesn't equal, so the explanation mark is, right?
Right, exactly, yeah. So I could see that only the uneven numbers exist. Very good, thank you. I see that it's 9 o'clock. Is there any more questions or?
I have a question. How would you use the for loop in this example instead of the list comprehension?
Okay, yeah, I can rewrite this indeed to using for loop. I'm sorry. I'm used to my editor, so then I have shortcuts that do stuff, but in the plain text editor, that doesn't work. What I would do is I would first introduce the list that I'm going to return, and I make that an empty list. So I want to return a list with only the even numbers. So I create an empty list with a logical name. So for instance, even numbers. And I just set that equal to an empty list. And then next, I'm going to iterate over this list that we got from the outside. So I would say for number in list of numbers. So this will iterate over all the numbers in the list. And then I would say I would need an if statement to check whether the number is indeed even. So this will come back to this basically. So if the modulus of 2 of that number equals 0, so this basically means is the number even. Then we append that number to the empty list that we created. So as we saw in the example with the lists, we can use the append function to add a number to a list. So I append that number to this empty list. And yeah, then at the end, outside of the for loop again, I would return even numbers. And if we now execute this, then you can see that it indeed returns the even numbers. Does that make sense, or do you have questions about this? Or
yeah, it makes sense. I got it. Yeah. Just the step of adding the numbers to an empty list. That is that's quite clever. Yeah.
Yeah, I think we discussed a lot today, so I think we have enough to process. And also at the end we had the small assignment, which really required you to think about what we discussed. And I'm not sure if you, because at least I have a link on where you can practice more of these kind of exercises. I thought you also mentioned that you put them in the slides somewhere.
very last slide, I put 3
Yeah.
links. So this is the official documentation of Python. So every function that exists in Python you can find over here, but it's also always a bit it's official documentation. So it's like reading a paper. It's not very user friendly. It's all in there, but if you want to have like quick and easy to read examples, then I would go to any of these 2, Geeks for Geeks or We3 schools.
Yes.